All right, heroes, welcome to the Digital Defender program. It is time to power up those keyboards because we are about to dive into a coding quest of truly epic proportions.
So in this explainer, we're going to walk through a really unique educational mission. It's all about turning students from, regular digital citizens into actual digital defenders. And how do they pull this off? Well, they build their very own video games from scratch to teach other people about cybersecurity.
Okay, so every great quest has to start somewhere, right? It always starts with a choice. And for our digital defenders, that first step is accepting one of 4 pretty critical missions. This choice? It's a big one. It's going to define their entire project, from how the game plays to the exact security lesson it teaches.
And what's really clever here is how each mission links a specific game genre to a core cybersecurity concept. So let's say you're new to coding, no problem. You might go for Mission 1, Inbox Inspector. It's a collector-style game where you're dodging phishing scams. Super intuitive. But maybe you're feeling a bit more adventurous? Then you could try Mission 3, Virus Blaster. That one's a classic shooter where you are the firewall, blasting malware before it can do any damage.
Right, so before you can build a defense, you gotta have the right tools. Students don't just get thrown into the deep end here. Instead, they level up their skills through this really well-designed skill tree. It makes sure they have all the powers they need before they face that final challenge.
So the journey kicks off with the basics. You gotta understand the enemy. That means learning cybersecurity fundamentals from approved sources like Grok Learning. From there, every lesson adds a new tool to their belt. They'll learn about algorithms by making a collector game, then they'll tackle decision-making with a chase game, and then get the hang of loops by building a shooter. See how it builds? By the time they're done, they have this complete coding toolkit, and they're ready for anything.
Okay, the first power-up they unlock is something called algorithmic thinking. I know it sounds super complex, but trust me, it's not. It's really just a clear list of steps to solve a problem. That's it. And this is the absolute bedrock of all coding.
Here's a great way to think about it. You wouldn't just run headfirst into a boss battle without a strategy, would you? Of course not. Your algorithm, well, that is your game plan. It's that exact sequence of moves, jump, dodge, attack, that's going to lead you to victory. All right, next up, the next crucial skill, the loop. This is basically a coder's superpower for efficiency. Seriously, it lets you repeat actions, like making enemies appear or constantly checking for threats, without having to write the same line of code over and over and over again. And here's the cool part, how that connects to the real world. Think about a firewall. It doesn't just check for a virus once and call it a day, right? It scans constantly. A loop is exactly what makes that possible. It's this persistent, repeating defense mechanism, working 24/7 to keep the whole system safe.
So their coding skills are leveled up, and now it's time to map out the strategy. Because here's the thing, coding is really only half the battle. A true digital defender knows that planning is, well, it's everything. And that's exactly where the project portfolio comes into play.
Now, this is so important to get. Computers don't think. They're extremely literal. They do exactly what you tell them to, even if what you told them to do is completely wrong. And that is why having a detailed blueprint is absolutely non-negotiable. You've got to have one before you write a single line of code.
So for this blueprint, students use 2 main tools. First up is pseudocode. Just think of that as the step-by-step script for their game, but written in plain English. It just makes the logic super clear. Then they make a flowchart, which is basically a visual map of every single decision, path, and possible outcome in their game.
And of course, every hero needs to document their journey. This is where the development logbook comes in. It's like their journal. They need at least 7 entries, and in them, they'll record what they built, what bugs they squashed, and the clever solutions they came up with. It's pretty much a chronicle of their whole problem-solving adventure.
Okay, the skills have been learned, the plans have been mapped out. You know what that means? It's time for the final boss battle, the assessment. This is it. This is where students combine that awesome coding toolkit with their strategic portfolio to create a fully functional, totally educational game. So how do you win this thing? Well, that portfolio, the plan, is super important. It's worth 1/4 of the total score. But the main event, the big one, worth a whopping 75%, that's the working code. The ultimate goal is to hand in a polished, playable game that actually teaches its cybersecurity lesson. Let's check out a great example of this in action. It's a project called Burgers and Lemons, and it's a simple but absolutely brilliant game for teaching phishing awareness.
The whole mechanic is just so intuitive. You move your character around, you collect the good stuff, the burgers, and you avoid the bad stuff, the lemons, which of course represent those pesky phishing links.
So how does a game like this actually come to life? Well, this timeline from the developer's logbook shows you the whole process, and you can see it didn't just happen overnight. It was built piece by piece, day by day. And honestly, that's exactly how real software gets made. One feature, one bug fix, one tiny improvement at a time.
Okay, so after all that hard work, the coding, the planning, all the debugging, what's the real takeaway here? What's the point? Well, this whole quest is about so much more than just making a simple video game.
See, the students don't just end up with a game. They walk away with this incredible new set of skills. We're talking algorithmic thinking, visual planning, the kind of resilience you only get from debugging really tough problems. And maybe most importantly, they gain this deep, hands-on understanding of what it actually means to be a responsible digital citizen.
And that really brings us to the final, crucial question, doesn't it? In a world that is just packed with digital threats, how do we actually teach the next generation to be safe, to be smart, and to be responsible when they're online?
You let them build the defense themselves. It's that simple. You don't just tell them how a firewall works, you let them build one. Because real, lasting understanding, the kind that sticks, it doesn't come from memorizing a bunch of rules. It comes from creating the solutions and becoming the defender yourself.